Good morning, students. Welcome back to Embedded System class. In today's class, we are going to see the concept of ARM core data flow model. So basically, in the previous class, we have discussed about the ARM, right? What is ARM processor and what is the difference between RISC and CISC kind of architectures, right? So RISC is what? Reduced instruction set computer. CISC is what? Complex instruction set computer. So in that, we have seen that the difference of both. What is a RISC and where it is going to be used. So for doing the RISC, the programmer needs to be very skilled because we are reducing the instructions. The instruction may get the complicated because huge number of bank is there that we are reducing into small size. So when the size is being increased, the more concepts needs to come into pictures. So that means this ARM kind of architectures are considered to be the RISC, reduced instruction set computer. So based on that, we are designing the ARM processors. So basically, what is ARM processors? ARM processor completely is a type of load store architecture based. What is it? Load store means that is nothing but pipelining. In the pipelining, I have explained you, when you want to fetch the next instruction while the first instruction is in execution mode, so that particular thing is called as pipelining. So in that, we have seen this thing, right? What are the things we have seen? We have seen fetching, decoding and executing. So fetch, decode and execute. So this fetching, decoding, executing, what it is going to do it? It's going to perform the pipelining of the ARM processor. So basically, when you want to design the ARM kind of processors, what all the different types of ARM processor you are seeing, ARM 5, ARM 7, ARM 9, ARM 11, different types of ARM processors we do have. So all is going to perform these particular operations. So meaning is that, so when the instruction is going to be fetched, fetching means we are giving the source content to the registers to get executed. So first it will fetch, it will give, then it will pass to the decoding as per the machine code. It is going to compatible with the machine code, then it is going to execute it. So this is nothing but, this is the pipelining concept. So that also I have explained you in detail in the previous class. So in today's class, our topic of discussion is ARM core data flow model. So basically, how data is going to be flowed in the ARM kind of processor, right? So in the next class, we will see its complete architecture, but before that, you just see this ARM core data flow model. So in that, completely it consists of the five things. One is the register file, because if you do any kind of processor or any kind of architecture, register is the must. Without registers, you can't do any kind of functions, right? So first thing is that registers files we do have. Then how it is going to use by the barrel shifter and MAC. What is this MAC is called? MAC is nothing but multiply accumulated unit. So when you want to see any addressing of any kind of what we call registers or any types of processor, we should have a MAC address will be there and your IP address, right? When you want to design any kind of what we call a system which you want to communicate, so in that we'll be having MAC address, we had IP address, we had default gateway, we had DNS server. There are different concepts which you are going to learn in mobile cellular communications or wireless WSN, wireless sensor network. The different domain of communication you are learning in that complete detail wise. But right, as of now in embedded system, we are going to see how it is going to work it, right? So as I said, your ARM processor or any kind of processor by using Mnemon architecture or Harvard architectures, all are depends upon load and store. So loading and storing, this is called load and store. So based on that, we have designed one data flow model, how data is going to be flowed. So basically, first we had instruction decoder. What is the use of instruction decoder? There are different points we are having in the processor. There will be a program counter will be there, instruction decoder will be there. In registers, we had accumulator, base registers, right? What is this accumulator? Accumulator is the one which will going to take the arithmetic and logical operation answer. That is nothing but result. Whatever the result is there, we will store in the accumulator. So that is what we are using. A registers, B registers. A consists of R and operand. B consists of R and operand, means the content of this particular A and B is given. So in that, first thing, it is going to check for sign. So whatever the sign extent is there, means the sign bit, is it sign or unsigned bit, they will check it out and it is passed to the register file. So register file is how many bits? Totally it is 32 bits, because your processor is of 32 bit size. That's what it is, 32 bit is there. In that, registers we are considering, and it is going to go for PC. What is a PC useful? PC is called program counter. So what is the use of program counter? It will count the number of instructions. It will count the sequence of the instructions when you want to perform the operation to the particular register. So PC, it will pass to the, where it is going PC, it is taking directly to the address. It is going to check what is the source and destination address, how the opcode and operand is going to work. What is this opcode means? If you don't see the opcode, operational code, whatever the ABC will write, that A default has some code by the ARM processor. So that is what opcode. Operand means what data you are passing to it. So you have seen in the microprocessor and microcontroller that if you are using the accumulator AX is equals to 0003, right? Like this we have passed. So what is this A? This is your register. So it has specific code for that particular register. That is opcode. What the value we are passing? That is called as operand. So opcode and operand both are different, and it will be stored. Where it is going to be stored? It will be stored in the register file in a barrel shifter. Okay, so I have said just now PC, it's a program counter. It's somewhat, it is not visible, so I just check it out. So it's program counter. So based on that, it is going to take the opcode and operand. So after getting the opcode and operand, next thing is that it is going to pass to the barrel shifter. So here the MAC address of that particular data will be checked out. So in the shifter, what it is going to do it is going to shift or rotate, or it is going to go for all different types of operations that can be done, or shifting, or left shift, right shift, they are rotating, right rotate, left rotate, with carry, without carry. You may have seen that in MPMC last semester classes. MPMC, what you have seen, there are different types of instructions we can pass to the R registers: rotating left, rotating right, with carry, without carry. So there are different instructions which we can done by using the barrel shifter and the MAC. So MAC is nothing but multiply accumulated unit. So it is going to check it out, and it is going to multiply that particular content if you want to go for multiplication of it. Next thing, what are all the things we are doing? We are passing to the address register. What is the use of address registers? It is going to locate the address of the source and destinations. If the source and destination address is being used in the programming of ARM, it is going to be used, that particular part. And next, whatever data we are placing in the register file, it is going to be stored by bank of 32-bit registers. As I said, it is a 32-bit processor, so it is going to be stored that one, whether it is signed bit or unsigned bit, and it is going to perform two types of operations. One is the write. Write means we are writing the instruction to the, we are writing the content or a program in the processor. That means data we are inserting, that is write operation. Then after writing whatever the things we are passing, if it is done, if you want the next instruction, it is going to be increment, means first address location to the next address location, it is going to increment to write the next instructions. Like you want to perform the addition, subtraction, multiplication, normal, all types of arithmetic operations. What we will do, we'll write accumulator content, then we'll write B register content, we'll write add A comma B, then we'll stop it. Int 03, like that we have seen the programming, right? So what it is going to do it, every time address needs to be increment. So PC value always needs to be increment until and unless you are going for push operation, inserting. As soon as you have done with inserting, you want to retrieve back, that is called read operation. So read and write, we have two operations. Here we have to retrieve back, that is called pop operations. So that time whatever the program counter it is there, it is needs to be decremented, right? That both the things we know it. So this is the just data flow model of your ARM processor, where it is going to see the flow of data based upon the instructions what we are passing to the program counter. That one is passed to the ALU. ALU is going to perform arithmetic and logical unit of whatever data we are passing. Then it is going to be checked by the result. So what is that result means? What? Here onwards, again it is passing here. It is here is the result is going to be there. So if the content is still is there, it is going to increment it. Then it is going to see the address. This is the address lines. This two arrow marks, and this one it is address, because it's address registers. You may have data registers and address registers. Data means the inputs what we are giving. Address means the location where your data is being stored. So this thing is again is checking here. I'm storing the result over there, and it is passed to the register file, and this operation keep on doing it until unless your data flow of that particular ARM core has been achieved. And then next is ALU. So as I said, ALU is going to perform arithmetic and logical unit, and MAC is what? Multiply accumulated unit, which takes the registers of RN and RM from A and B both buses and compute a result. The data processing of instructions with the right result in RD is passing to the register file, and load and store instructions used by the address will be used in address, and it is going to broadcast on the address bus. So this is how the data core model of ARM processor has been designed. So in the next class we will see the architecture and we will see the memory and features of ARM. And then we'll go with the ARM registers and properties of ARM, and what are the modes it's going to work, and what is 3-stage pipelining, 8-stage, 6 stage. There are different stages of pipelining we do have, that we will see. Thank you. So make a note of this registers model and make the running nodes, so that it will be easy for you to understand the upcoming concept in embedded system.